we want to continue our work on the inference for the difference between two proportions for two separate populations. And now we're going to work on confidence intervals. So we have the formula here. It's a giant formula. And of course, just as with hypothesis testing, we're not really going to do it, right? We're going to use the same StatCrunch instructions for a hypothesis test that we're going to use for our confidence interval. Stat, proportion stat, two sample width summary. Now, the only thing to note besides this, the point estimate, of course, is the middle of your interval. It's the center of your interval. And then the margin of error is this back piece. So this is the point estimate, plus or minus. This whole thing is the margin of error. But we're not going to do this formula by hand. We're just going to use technology to do it. The other thing to note is that just as with the hypothesis test, the list of requirements has gotten a little bit larger. There's this new requirement that we haven't had before this chapter. And then these requirements that we've had before have been doubled. So we have to check them for both groups. All right, so let's go look at an example. Researchers from the Pew Forum on Religion and Public Life interviewed two random samples of people. Both samples had 1,500 people. In 2002, 645 people expressed support for stem cell research. And in 2009, 870 expressed support. So just so you understand what's happening, in 2002 they grabbed a random group of 1,500 people, and 645 of those people expressed support for stem cell research. And in 2009, of the 1,500 people they talked to again, but they're not the same people, they're a different group of people, 870 expressed support. And we're going to let group 1 be the 2002 group. Okay, so again, that's an arbitrary distinction. I just chose one because it's convenient to have one for the notes. And I'll do that a lot of times in the problems, but just be aware it's made up. It doesn't mean anything. I just picked one of the years. All right, so I'm going to have group 1 be 2002, so x1 over n1. Well, x1, this is 2002, was right there. That's x1. It's 645. That's how many successes there were, divided by n1 is 1,500 people. And similarly, x2, well, that's the 2009, so right there, that's x2. And n2 is also 1,500 people. So x2 over n2, that would be 870 over 1,500. And just for the sake of knowing what that means, because looking at the fractions, it's a little hard to direct compare. I mean, we know in this case they have the same denominator, but it's not quite the same thing. So let me grab decimals here. And let's just find what these are as a decimal. So let me close these pieces out. All right, so 645 divided by 1,500, which is that value, and 870 divided by 1,500. So we get 0.43 and 0.58. Okay, so let me write those in. This is 0.58 over here, and this is 0.43 over here. We knew this was lower, but having decimals like that makes the direct comparison a little bit easier to understand. All right, so now let's look at part B. Now part B says to construct a 99% confidence interval for P1 minus P2, right? The difference in those proportions, not these two proportions, because these are P hats. It's P1 and P2 are the population proportions. It's the difference in the proportion of people who support stem cell research for everybody, right, for the 2 years. Just give the result, do not show work. Okay. So just give the result. In other words, I don't want to see that formula. It's big, it's ugly, and it's unnecessary, right? So we're not going to do it. What we are going to do is write down a little bit of our StatCrunch path for ourselves. So I'm just going to write that down so that way we know it. So StatCrunch, we're going to go stat, proportion stat, I'll just put it down here, to sample with summary. Okay, so let's go do that. Oh, I just want to remind everybody. I'm just going to put it over here. Note. Okay. X is the number of successes. I know we wrote it on a previous page, but it doesn't hurt to write it again. N is the number of observations. And for the record, I didn't ask for them, and it's not necessary, but you might also want to note that Q1 hat will be 0.57, and Q2 hat will be 0.42, because they have to add up to 1, right? These are complements of each other. Again, it wasn't asked for, but for your own notes, just so you know how to find these values, it doesn't hurt to write it again. Okay, so let me go to StatCrunch. All right, so in StatCrunch, I'm going to go to Stat, Proportion Stat, to Sample with Summary. Now my number of successes was 645. My number of observations was 1,500. And for my second group, it was 870 and 1,500. And I want to make sure I select a confidence interval, and then I want to tell it the confidence level, which in this case is 99. So I'm going to make that 0.99. And that's it. That's all you need. You just click Compute. And the confidence interval itself is the lower and upper values. So we have a negative 0.1965 and a negative 1035. Okay, I'm writing those down so that when I bring up the camera, there they are. It's done. That's it. That's your confidence interval. Right, a confidence interval is always a lower and then an upper number. No formula, no substitution, nothing. All right, now let's remind ourselves how to calculate the point estimate of the difference in the proportions. So at this point, we can do this two ways. So one, the point estimate is a known thing. It says it right here. It's P1 hat minus P2 hat. So we could just do it that way. And I'm going to have this work this in two different ways. So method one would just be using the definition, right? For this problem, the point estimate is P1 hat minus P2 hat, which I happen to know P1 hat because I found it above. It's 0.43 minus 0.58 I'm just going to grab decimals real quick. Yes, I can do that in my head, but I want people to see how to do it if they can't. So 0.43 minus 0.58 gets us negative 0.15. All right, so that's our estimate for the difference. And that's perfectly fine. I mean, we can use that, but we have learned another method. Back in chapter 9, let me grab the chapter 9 flow chart here. So we also saw the point estimate is the lower plus the upper divided by 2. So that's another method you could use. It's a little sidestepping formula, a little cheating formula that we learned that you can use if you have the interval. So that's method number 2. And it didn't specify which method. You don't have to do both methods. Of course, you're going to do them both for your notes. That way you have them both available to you. But we're just going to use a little formula here. So you take the lower, you add the upper, and you divide by 2. In other words, you're taking the average of your lower and upper numbers. My lower number is negative 0.1965 plus my upper number, which is negative 0.1035. I close parentheses and I divide by 2. So let me grab Desmos. My computer is being annoying. Okay, so parentheses, negative 0.1965 plus negative 0.1035, close the parentheses, divide by 2. And we get negative 0.15, which we already knew, of course, but I just wanted to prove to you both methods work, and it's just a question of which method you want, right? This method came out of the Chapter 9 flowchart. Actually, we saw it earlier in section 9.1, but that's where you can find it. All right, what about the margin of error? Okay, well, finding the margin of error using the interval. Okay, so why do I say use the interval? Well, because the margin of error is actually the back half of this. This is the real margin of error. It's the z times this big square root and all this. And we don't want to do that, right? We already said we didn't want to deal with those formulas. So how could I find it from the interval? Well, it's on the same spot in the flowchart. The margin of error is the upper value minus the lower value divided by 2, right? Because the upper minus the lower creates the width, and the width divided by 2 is your margin of error. Okay, so let me write that down. So margin of error is the upper minus the lower divided by 2. And we can say we got this from the Chapter 9 flowchart. Okay. Well, my upper number is negative 0.1035, and I'm going to minus a negative 0.1965. And then we're going to divide it by 2. Okay, so now I'm going to type that into Desmos. And I wanted to do this problem in particular because I wanted there to be 2 negatives. You can see how that works. So parentheses, negative 0.1035 minus negative 0.1965. Close parentheses, divided by 2. Now, if you're thinking, well, minus a minus is plus, yes, you could do that as well. So I could take this same piece and change that to a plus, and you'll get the same answer. So it's 0.0465. And I put that right here. All right, so that piece is done. Now, what about interpreting the confidence interval? Okay, well, we learned that in the Chapter 9 flowchart as well, and it still hasn't changed. So we always start with the we are so % confident. So for us, it'll be we are 99% confident. So that's a piece that we fill in. So I'm going to put a little blank there. 99% confident that the true, and now it was before proportion or mean, like those were our choices. But for us, it's going to be the difference in the proportion. Let's see here. So difference in proportions, you can see that from the title. And it was the proportions of people that believe in stem cell research, right? That support stem cell research. It's right up here, right? Difference in the proportion of people that support stem cell research. Okay, so you have to fill out whether it's proportions or averages, in this case proportions, and then you have to put the context in, and that's what this is. This is all context, right? And then you just write is between, and you put your 2 numbers. And then it's up to you. If you want to leave them as decimals, that's fine. Or if you want to write them as a percentage, that's fine too. It only works on this case because these are proportions. When it's, if I'm going to make them both percents, I should make them both percents. So 10.35%. So there's your lower and there's your upper. Now the last piece. Does this confidence interval suggest that there's a significant difference? Okay, well that's key. So difference. Okay, so in chapter 11, and this is going to be something that's going to hold for the whole chapter, The null hypothesis is always that they're equal to each other, that group 1 and group 2 are equal, either their means or their proportions, which means when you subtract them, remember the other way of writing it, it would be that it's equal to 0, right? So there's no change, there's no difference. That is always the null hypothesis, right? There's no difference, that the difference is 0. Okay, so you have to ask yourself, is 0 in my interval? Right? Because if 0 is in my interval between these numbers, then there's not a significant difference. And if 0 is in the interval, then there is a significant difference. So if you look at these numbers, negative 0.1965 is here, negative 0.1035 is here. My interval is anywhere between those numbers. 0 is over here. So 0 is not in the interval. And so we would say because, oh, hold on, had to change my pen. So because 0 is not contained within the interval, there is a significant difference in stem cell support. Well, stem cell research support. Okay, so I just want to segment that off. This piece right here is going to be true for the whole of the chapter, right? And that leads us to the box down here. To show a significant difference, your interval must not contain 0. Must not contain 0. Okay. In other words, if the interval contains 0, right? In other words, contains means is between. If 0 is between your two numbers, right, contains 0, then there is not a significant difference. And again, the word contains, don't get confused by that. Contains means is 0 between your lower and upper, right? So that's what this means. Is 0 between the lower and upper bound. Right? That's what contains zeros mean. So if 0 is in there, then there is not a significant difference. If 0 is not in there, then there is a significant difference.